Chapter 18, Aqueous Ionic Equilibrium. I like this quote. In the strictly scientific sense of the word, insolubility does not exist. And even those substances characterized by the most obstinate resistance to the solvent action of water may be properly designated as extraordinarily difficult of solution, not as insoluble. So in 1A, a lot of things are kind of black and white, and then in 1B, we kind of burst that bubble and let you in on the secret that actually everything is gray. Nothing is absolutely black, nothing's absolutely white, everything's somewhere in the middle. And it's the same with the solubility of compounds. So the first section talks about the danger of antifreeze. Every year, thousands of cats and dogs die from ingesting antifreeze. This is the ethylene glycol containing antifreeze. There are other antifreezes out there that are less appealing to pets, but this is the standard one. So why would an animal drink antifreeze? Because it tastes good, right? It has a sweet taste. Ethylene glycol is an alcohol. And the first symptoms of ethylene glycol poisoning resemble drunkenness. The problem is that it's metabolized to glycolic acid, which is an acid that gets into your bloodstream and affects the pH of your blood. Blood pH is really, really important because there are a lot of proteins that only function correctly within a narrow pH range. So in humans, your body regulates the pH of your blood between 7.36 and 7.42. How does it do that? It maintains the pH using buffers. And that's one of the things we'll be talking about in this chapter. A buffer is a chemical system that resists pH changes by neutralizing added acid or base. So it can kind of do either or both. So an important buffer in your blood is a mixture of carbonic acid and bicarbonate ion, or hydrogen carbonate ion. So carbonic acid, as its name suggests, is an acid and can react and neutralize hydroxide ions, forming water and bicarbonate ion. Bicarbonate ion is the conjugate base of the weak acid, and so it can act as a base and will neutralize added acid. So if there are large enough, that maintains your pH in your blood, but if there are large enough quantities of glycolic acid entering the blood, it overwhelms the capacity of the buffer. The buffer can only handle so much, and then the pH of the blood starts to drop to dangerous levels. Low blood pH results in acidosis. This is something that diabetics have to worry about. It affects the equilibrium between hemoglobin and oxygen, and that's the most immediate threat to your health. So hemoglobin is in an equilibrium with oxygen, so the hemoglobin picks up the oxygen and will release the oxygen, and this equilibrium involves the hydrogen ion. If you have a low oxygen concentration, the equilibrium will shift to the left and the hemoglobin will pick up oxygen, and then it travels to part of your body where the oxygen concentration is low, and that'll cause this to shift to the right, and it will, I'm sorry, I did that backwards. If this is high, it'll pick it up, it shifts to the right. When O2 is low, it shifts to the left and releases the oxygen. The problem arises when we have an excess of hydrogen ion. That causes this to shift to the left regardless of the oxygen concentration, and the blood's ability to carry the oxygen is reduced. The result would be initially hyperventilation, then coma and death. Not cool. One treatment, which works if it's administered fairly quickly, is giving the animal ethanol. Ethanol is the alcohol that humans consume. And the reason this works is that the enzymes that metabolize the ethylene glycol are the same ones that metabolize the ethanol, and they prefer ethanol. So if you keep them busy metabolizing ethanol, they'll let the ethylene glycol go by and not metabolize it, and then it just passes through in the urine and doesn't hurt anything. Any questions?